Okay. Class example 6.
Using the 23 years of annual use of the Los Angeles index units frequencies and use of the highest time values using the
Thank you very much. So again, we are using the same set of data, that Los Angeles, California data, okay? Now, if we go back to our previous class, we said that we have two common frequency analysis methods. One is the plotting formula, another one is use of frequency factor. So frequency factor, we already did that for the Pearson tree distribution type. Now we will do one class example for plotting formula. Okay. So this class example 6 is all about the plotting formula. Now for plotting formula, the main thing is you need to find this rank M. Now, whenever we say rank, what does that mean? Like obviously you have some rank, right? Among you, and we professors have some rank like major, lieutenant colonel, colonel, something like that. It's like who is on the higher position and who is the second, third position, something like that, right? So we will do the exact same thing here. We will find rank number wise, like 1, 2, 3, 4, 5, 6. But we don't need to do that for 23 data points. We will only do the highest 10 values here. Okay, that's what they said. If they said that, okay, do that for 10, 20 years, we will do that. But they only said that for highest 10 values, that means we need to rearrange our Los Angeles, California data from highest to lowest, and then we can find 10 highest values, right? Now, the Excel sheet you don't have all the headings for the table. So make sure you write down that on that table. And on your paper copy, please make a note that you are doing this problem on Excel. Otherwise, before test, you will be so lost. On paper copy, make a note, you did that on Excel. Okay, so they need to, they ask you to find probability or frequency and the return period, right? So we know return period is 1 over probability, which is good. Once we find the probability, we can find return period. Now, for probability of frequency, the equation is P equals to M over N plus 1. So what is N? 23 years, right? So N plus 1 is what? 23 plus 1, 24, right? Oops. Now, the only thing you will make mistake here is finding the rank. So we will spend some time on rank. How can we do the rank? But what is the best way to find highest 10 values? What is the best way? You can do that manually. That is one way. Or you can just copy this table to somewhere else. Do you know how to sort out data from highest to lowest, lowest to highest, A to Z, Z to A? Okay, so that's what you can do, or you can just select manually the 10 values manually. Okay, so I'm using the Excel. If you want to do that manually, that is absolutely fine because it's on the 10 data. So I will copy this year and Aniston and Los Angeles data, and I will paste that on a different here. All of you can do that. Are you following? Okay. So since I don't need the Aniston, Alabama data set, I will delete that because I don't need that. So this is the data set. Now I want to rearrange these in like highest to lowest that way. So I will select that. I will go to insert, not insert, home, here, sort and filter. All of you can do that. Just select the data set, go to sort and filter.
So you select it.
Yeah, at first you need to select that. Okay. sort and filter here.
Yeah.
Now go to the custom sort. Most of the time inbuilt one works well. Just to make sure we're doing it correctly, I will use the custom sort. And it says that sort by. So I want to sort by Los Angeles, California data. So I will click that one. And I want to do that largest to smallest. So I will click largest to smallest, that one. Everyone's following? Okay, good. Then I will click OK. And now all of the data set they are rearranged in a 24, 23, 23 that way. Now I need how many data points? Highest? Top 10. That's what they said for class example 6. So I will select 6, 1, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I will copy that. I'll paste that here. Oh, yes. Okay, copy. Yes. Okay. All of you got the same data set, kind of. Okay. Now probability and return period, those are two easy parts, as I said. The only problem you will have the rank. So the top one should be ranked what? 1, right? What will be the second one?
2.
What will be the third one?
3.
Now, second and third one, they have the same, 23, 23. So they can't have different rank. Like if two people have same qualification, same years of experience and everything, they will have same rank, maybe like major, captain, something like that. So in that case, since we have 2, 3, we can't use 2 and 3. We will just use the maximum one, 3. Like both of these will be 3. Instead of 2, we will skip 2. We will use 3 because that will be the rank. Now this one is 4 because there is no repetitive one, right? What about the next one? What about next 3? 19, 19, 19. 8, 8, 8. Great. So you understand, and the last two will be 10 and 10, right? Right. So that was the hardest part for this class example, just to get the correct rank. Now you can work with next two columns very easily. And M is 23 because they said that using 23 years of data set. I'm increasing the font so that N is 23. So what will be N plus 1? 24, and M is what? For the first one is 1. For the second one is 3, right? I'm giving you the very first two values so that you can check your answer. M will be 23 and N plus 1 will be 24. The very first number should be 24 years different period, and the last one is what? Even what the very last one? 0.4 or 0.24? 2.4, yes, that is correct. That is correct. That should be the very last one.
So M is 23, so put M and the other 23.
No, M is ranked, this one here. M is that one. 1, 2, 3, 4.
Oh, okay.
N for Nancy, that is 23 years. And M for mango, that is you need to find 1, 2, 3, 4. Oh, I have to do that a lot, like in for Nancy. Like whenever I need to spell my last name, A for apple, A for frog, I for red, I for India, in for Nancy. Over the phone. And they get confused with my first name, it's P or B. So sometimes I get my name as Bandina. So because I used to say B for boy, they had T for toy. Sorry, I said T for toy, they had B for boy. So now I say T for Texas. Yeah. We and my husband's last name. Oh my God, that's harder than my first and last name. So I need to spell out our name a lot. Okay, so all the numbers here. Just check your number if you got that or not. We have less than 15 minutes. We will try to do something for class example 7. I'm pretty sure you will be able to complete that, but that's fine. As long as we make some progress. So all of you got that class example 6 properly? Everyone? That one was easier, right, compared to class example 5. And that would be easier compared to class example 7 as well, because again for 7 we need to use some table. Okay, great. So for class example 7, we don't need the Excel. We can do that on paper copy. So let's go back to class example 7 here. So that was class example 6. We did that on Excel. Now for class example 7, who will read the class example 7?
Figure 4 has been estimated as 1,000 seconds, 10-year as 52,000 seconds. Determine a 25-year flood assuming annual rainfall follows a normal distribution.
Thank you. So when we say normal distribution, do you remember what should be the shape of that distribution? The bell-shaped curve, right? That's the normal shape distribution. So here they are saying we have 2 years data and the 10 years data. Basically, we have only 2 set of data, and they are asking you to find 25-year flood, assuming the annual rainfall follows a normal distribution. So whenever they give you the distribution pattern, we kind of know we can use actually general expression for that one, right? And using a table, we can find K, Z, whatever we need. So that's what we will do. Now, before doing that, I want you to identify some word here. It says that it's normal distribution, right? So the normal distribution, if I go back to your previous class lecture, here, that was the general expression, right? X equals to X bar, K multiplied with S. And that K is different for different type of distribution. For normal distribution, what is the equation? X equals to X bar plus, instead of K, we are using Z, right? And from where we can get the Z value? Table B1, and you all should have table B1. I gave you today. Yes, Micah.
So will we have this thing like on the test?
Like what will be the Z and everything?
Yes.
Yeah.
Okay.
Yeah. Yeah, you must have, otherwise, like those are kind of the equation you need to use. So yeah. Like you have means this one, you are allowed to write down this equation, but the table I will give you.
Okay.
Okay. Okay. So for the Z, all of you have your table B1. Everyone? Okay. So for B1, it's a little bit difficult than B2. So I think I need to spend some time on that. We will do that. So what we will do, since it's normal distribution, the equation is X bar Z multiplied with S, right? Now X equals to what? Mean. S equals to standard deviation and Z from table B2, right? That's what we know. And let's find out what are the given values here. But from the given values, are you seeing any mean or standard deviation number? No, right? We're not seeing that. So what we will do, I will write down two sets of data on two sides so that we will do something. So since it's 2 years flood, I will write down T2, 2 years, T10, 10 years, okay? Once we know the T, what is the next thing we can do that very easily? If we know the return period, we can find the probability, right? 1 over T. It's just vice versa. If we know the probability, we can find return period. If we know the return period, we can do the probability. So that's what I will do. So P2 will be 1 over 2 equals to what? This one is 0.5 and this one is 0.1. Okay. Now, all the frequencies here, like all the data points. So X2 is 40,000 CFS. X10 is 52,000 CFS, right? Now, we have two sets of data and we still have two unknowns, mean and standard deviation. We kind of know that using two sets of data, we can find X and S, right? X bar and S. So we will try to do that. But once we do that, then you will see we don't have all the values. So we need to do something else. Okay, so I will just write down this value like X2 equals to X bar Z2S. I'll write down the same thing here. Yes, right? Okay, so I have already 40,000. I don't know the X bar. I don't know the Z. I don't know the S. The same thing here. I know it's 52,000. I don't know the X bar. I don't know the Z. I don't know the S. So basically we have three unknowns, but one good thing is for Z, we can use one table. Which table is that for Z? Table B, actually it should be B1, right? Okay, so three unknowns, two equations. That means we can use the Z value from the table. Now, the next step will be understand the table a little bit. But before that, up to this point, are we good, everyone? Sure? Okay, so let's go to table B2 and you may have some hard time to understand that, but we will try our best to explain that. So this is the table. Are you seeing that bell-shaped curve? And all the values here, like all these values, this is actually FZ. Okay, are you seeing this? If I draw that, this is 0, the final or highest number is 0.5. Okay, and if you look at that, the lowest number is 0, highest number is 0.499965, which is equals to 0.5, right? Now, all these values here, this is FC, all these values, like any other side, it's actually the PZ or probability. Now, how can we find Fz? That is actually 0.5 minus Pz. Okay. Now that is one thing from this table. We need to understand one more thing. Are you seeing, like on your copy, maybe it's not clear from here. Are you seeing the Z value 0, 0.1, 0.2 till 4 on like vertical this direction? And are you seeing on the horizontal direction, it's 0, 0.01, 0.02, something like that? So that simply tells you, if I just pick one single number, suppose this one, 0.4370, okay, that number, the Z value for exact that number would be 15 from this side and 0.03. So 15 plus 0.03 equals to 1.53. That will be the Z value for 0.4370. One more practice just to make sure we understand that. You will tell me this time, okay? So I picked that number. Can you tell me what will be the Z value for this number? What will be the Z value for this number? 2 plus 0.05, which is what? This one, right? Is that correct? Okay. Let's do one more practice. This time, this one. Tell me what will be the Z value? Three plus. Are we good up to this point? How to read this table? Because we will need that. Okay. Okay, that's good. And we also know Fz equals to 0.5 minus, like 0.5 minus Pz. Okay. So from your given data set, do we have any, we already have all the probability. Yes, yes.
So can you get back to-
On the table, this one?
So the 1.53 is.
Yes, yes, exactly, yes. So you can actually use this table both ways. If you know the Z value, you can find that Fz. If you know the Fz value, you can find Z, like vice versa, okay? Okay, so we already have 0.5 and 0.1. From these one, can we find what will be the Fz value? 0.5 minus 0.5, what will be that number? 0.5 minus 0.1, what will be that number? For the very first one, Fz is what? 0, okay, and for the second one? 0.5 minus 0.1, 0.4, okay, I will keep that one. Now, can you go back to that table and tell me for 0, Fz 0, Z value will be what? Okay, I just need 1 minute just to explain this and then we'll stop, okay? Okay, here, are you seeing any 0 value within that purple box? The top one, which is actually hidden behind the green color, but on your copy, this is actually 0. So what is the Z value for 0? Okay, so that will be, Z value is 0. And X bar is 40,000 CFS. Okay, I will stop here and